Okay, greetings, ladies and gentlemen. It's time for some geometry. Let's get started. In my other videos I posted in this series so far, we've covered all the core constructions, numbers 1 through 6, but here are the final three: how to make these shapes: equilateral triangle, square, and equilateral hexagon, inscribe into these circles. Now, the term inscribed is not one I've used in class so much, but it means exactly as it's stated in this core worksheet, that we want all the vertices to lie equally spaced along the circumference of the circle. So keep that in mind as we're moving forward in class. The term inscribed means exactly that. All vertices equally spaced on the circumference of the circle. Now, we're actually going in reverse order. We're actually going to start at the very bottom of the page and work our way up. We're actually going to do some bouncing around, but we're going to start with core construction 9. I think that's the one more than anything people got the best. They actually really tuned in. Everyone was pretty much able to make that flower, so to speak. So making a hexagon, I think, was just a small leap for them. So if that's not the case, or maybe you just need a review, it's not a big deal. Let's go ahead and review how to do this. Um, Again, it's about choosing the right distances and making sure that you have this sense that intercepting arcs create points that are equidistant from two other given points. So I want 6 equally spaced around here. I'm going to need a bunch of arcs to intersect, specifically 12 arcs. So to do that, though, the first thing we're going to do is set our distance to the only distance given, which is this radius. Again, it's pretty important you do this as well as possible, simply because we're going to be using this distance to make 6 separate points, and being a little bit off is not going to be good. So precision here, definitely. Now, from there, we just need to designate a starting point. It doesn't matter where. It can literally be anywhere, but I'm just going to put mine right there. So keeping the same radius distance, starting with a point I've designated, we're now going to start cutting arcs. Okay? I'm going to cut one pretty dark, because that's the one we're actually going to need for a point that's on the perimeter. But I'm going to kind of acknowledge, yeah, we've done this before. We've made the quote-unquote flower. In fact, that's one of the first things I asked you guys to do. So again, I'm going to make it dark and dark here on the circumference. That's where our point should be. Okay? So now I'm going to move this and rotate it actually now, so I'm pitting right here at the intersection of the circumference and the arc I just made. I'm going to repeat the process. So we're going to make an arc right here. Acknowledge that we're kind of cutting a full arc. Okay? And darken an arc again, intersecting. Now, I should be a little bit worried because it's not exactly perfect here, meaning I'm already a little bit off, but that's okay. Human error is going to happen. It's not a big deal. We're just going to keep on going. So step 1, determine this radius. Step 2, cut your first arc. Step 3, go to the intersection of the arc you just cut and the circle. Cut a second arc. And now it's just wash, rinse, repeat. We're just going to continue this for the entire circle. Okay? There's our first real intersection of 2 arcs. So we know we definitely have a hexagon pattern right here, or at least one of the hexagon points, I should say, right there. Again, just moving it over, putting in new spots. Cutting a second arc. I'm sorry, right now, what was that? 3 arcs, 4 arcs. Move it over, repeats. So again, you can probably look at mine and say, Mr. Collins, well, you're off a little bit right here. Yeah, I know that, guys. I said it was going to be off in the very beginning because as soon as I saw down was off, I knew they weren't all going to be perfect. But that, again, that's human error. But the technique here is still solid. So at the intersection of all these arc points, or points of intersection of all these arcs, that's how I'm going to find the 6 points I need to make my hexagon. So now we just play a little game of connect the dots. Okay? And we have a hexagon inscribed into a circle. Now, very honestly, if I had taken just a little bit more time, been a little bit more careful with my compass and my arcings, I could have gotten a much more precise picture. So I would encourage you to do so. Honestly, guys, you can't tell this, but I'm kind of working about 18 inches away from the table, so I'm doing a lot of leaning. It's hard for me to see directly into it. But that aside, we still have our hexagon. So we're going to take the same kind of technique and we're going to go up to construction 7. This should be pretty straightforward. If this side has 6 equally spaced points that make a hexagon and I want to make a triangle, well, I'm just going to skip every other one. In fact, I'm not even going to reproduce this diagram. I'm simply going to point out that if you have these, excuse me, if you have this hexagon, then choosing every other point is going to give you the triangle. Okay? So same exact thing, just simply taking not all the points you actually need. Those two constructions are very closely related. So again, I'm not going to reproduce them. I'm simply going to point out if you do the flower structure again and pick every other vertex, you have your triangle. And again, there are many different other triangles you could have picked. I mean, you could have gone right here, for example. And of course, orienting just kind of, since it is a circle, orientation matters a little bit less. Okay, so that's going to be the hexagon and the triangle. The last one we have is the square. Now, the square is, I think, the one that caused people the most problems, which is a little surprising because we only need 4 points. Now, again, you kind of have to consider where these 4 points have to be and the other lengths involved within a square. One we talked in the warm-up today about the intersections of the diagonals, the one that cross within the shape, need to be perpendicular. That's actually a huge clue to how we're going to do this one. Um, the first thing we're definitely going to need, though, is a couple points to start with. So instead of picking up a compass at all, I'm just going to pick up our straight edge and trace the diameter. And I'm going to know where these 2 points intersect the circle. That gives us 2 points of our square. We just need 2 more. Approximately, they should be about right here and right here. But again, think about the qualities of a square. I can't just put this line anywhere. Like, that's not going to form a square. 1 point, 2 points, 3 points, 4 points, that's actually not going to be a square. That's going to be more of a rectangle. The line I'm going to have to draw that I'm currently representing with this ruler is going to have to be actually perpendicular to the blue line that's already there. Now, if I only had a way to construct a perpendicular line. Oh, wait, I did that already. In fact, I would argue that's one of the very first constructions I actually guys performed. Constructing a perpendicular bisector, whoa, zoom out. Constructing a perpendicular bisector is what you were asked to do in construction 3. So again, we're going to recycle this basic technique, but now we're going to apply it to creating a square on this circle. So if we bisect this, I'm assuming going to rotate this so it's a little bit easier for me to work with. If I bisect this segment, it should pass through the center, and it should intersect in such a way it's a 90-degree angle. That would guarantee a square. So now let's go to our trusty compass. Okay, let's set our distance to be a little bit larger than half, as we've done before, and let's cut some marks. So there's 1, 2, flip it, pin it at the other point of the diameter, 3, 4. Okay. These 2 points should line up with the center. That's giving my check in terms of precision, and we see we're pretty good here. Okay. And we're going to draw our second diameter. Okay. So where this diameter is going to intersect the two sides of this other side, intersects the circumference of the circle, that's going to give us all 4 points that we need for a square. So final step is simply to connect. And voila, we have our inscribed square. So again, it comes down to not only using the compass, but use the compass to transfer distances. That's the big thing. That's the thing we have to keep in mind for all these constructions. All this tool does is transfer a distance that you set by with your compass by spinning your wheel there. So if this is all I can do, transfer distances, we have to kind of be very sneaky and math ninja-like on how we take these distances and find the points we actually need. In the case of this one, it was finding the the intersection of 6 different, or intersection to find 6 different points. In this one, we just needed 4, but we need them all spaced in a very particular way. Okay? So in my other videos, we covered constructions 1 through 6. Here we have 7, 8, and 9. So definitely encourage you guys to go back, review those videos if you need that extra help, kind of need the extra tutorial to get going. Another thing I'm going to encourage you guys to do is to, again, subscribe to this channel. If you are a YouTube user. If not, not a big deal. All these videos will be linked through my website, so you have access to them. I'm, again, currently looking in to try to provide these to be offline. I'm not being very successful with that at this moment, but I'm trying really hard, and I'll keep you guys updated as we go. So that's all I have for you guys for now. Thank you so much for tuning in and working hard on this geometry stuff. I know it's not easy, but I do appreciate you guys working hard. So until next time, that's it. This is Mr. Collins saying good luck.